Okay, so I'm going to look at a couple of questions to do with the differential equations. This is the first one I'm going to look at. So here we go. It says consider the differential equation dy by dx is f of xy, x and y, where f of x and y is y take away 2x. Okay, so we've got a differential equation. The first thing that we need to do is to sketch on a diagram the isoclines corresponding to f of x. Y is k, and k takes values minus 1, minus 0.50 and 1, and then we obviously indicate where they cross the y-axis as well. Okay, so the first thing that we need to remember is, well, what is an isocline? And we have this basic definition. So if we've got a differential equation dy by dx is some function, then the curve with the equation that function equal k is known as an isocline. Okay, so all we basically need to do for this is to say, well, in this case here k is minus 1, so I set my function equal to negative 1, I set my function equal to minus 0.5, I set my function equal to 0, and I set this function equal to 1. Okay, so there I basically end up with 4 linear equations, and I'm going to look, I don't know, something like that. So there we go, my first equation, y equals 2x minus 1, I've just rearranged that, and so on, and I can see the points obviously where they cross the y-axis. So that's my first part. So I've sketched my isoclines. The next part basically tells me that, well, the curve, I've got a specific solution, a curve passes through the point 0, 1 and satisfies the differential equation above, and I've got to try and sketch C on the diagram. Okay, so probably the best way to do this is to actually label these isoclines. This was when k was equal to 1, it gave me this line here. When k was equal to 0, I got this line. When k is equal to negative a half, I got this line. And when k is negative 1, I got this line. Now, what that tells me is that when the curve touches this point, this is what the gradient is going to be. So when it touches, and I know that it's my starting point here, so I know that point 0, 1. And I know when it touches this point, it's going to have a gradient of 1. Okay, so I know roughly it's going to look like that. It's going to have a positive gradient. It's going to be less than this, because this line here has a gradient of 2, so it's going to be somewhere looking like that, a gradient of 1. I then know that when it touches this second line, it's got a gradient of 0, so that's obviously going to be a maximum if it's an increasing function, and now it's got a gradient of 0, so this must be the maximum point. And then I know when it crosses this next line, it's got a gradient of minus a half, so it's therefore a decreasing function. And then when k is equal to negative 1, it's getting even more steep, and again it's a negative gradient. So I get some sort of curved function looking like that. Okay, so there's my sketch of C. And then the last part of this question said, state a particular relationship between the isocline f of x and y equals negative 0.5 and the curve C. And this is only worth 1 mark, so I don't think they're expecting us to do too much. But if we kind of look at our sketch, basically we can see that the curve and this line are perpendicular, and that's really all it wanted really. So it's only 1 mark, so I'm presuming they just wanted to see that from the graph itself. Okay, and then the second question, we've got to use Euler's method. With step intervals of 0.1 to find an approximate value for y on C when x is 0.5. Okay, so this is carrying on from the previous question. We've got, this is our differential equation, y minus 2x, that's the function. And then we also know that C, the value, the curve that we're looking at passes through 0, 1. So this is our initial point, this is our initial value. And then we need to set up our table that looks like this. So we've got n, and xn, yn, f of xn, yn, and then yn plus 1 equals yn plus h bracket xn, yn. Now this particular question is only worth 4 marks, which seems a little bit mean because these questions do take quite a bit of time to work through. So possible good exam technique on this would be to possibly come back to this question. If it's only worth 4 marks, it's going to take you at least 4 minutes. I think you probably do pretty well to do it in 4 minutes. Sometimes these are worth 6 or 7 marks. But anyway, we can start. The first bit, well, we just say, well, obviously the first n is 0, x of 0, the first term, we already know that x is 0, we know when the first term for y is 1, and then we put these two values, x equals 0, y equals 1, into this here, and so therefore I get 1 take away 2 times 0, which gives me 1. So this is f of bracket x0, comma y0. And then I need to find the yn plus 1 term, and I do that by doing, well, whatever the yn value is. In this case it's 1 plus h, well, the h is the interval, that's 0.1, times by my answer for this previous column here, which is 1, and that gives me 1.1. And then basically I just have to do the whole thing all over again, and I do it several times. So now my next step, so n is now equal to 1. Because I'm adding 0.1 each time, the xn value is now 0.1. I now take this new value here of 1.1 to be my new yn value. And then I basically put these two values, 0.1 and 1.1, into my function here. So I'm going to do 1.1 take away 2 times 0.1. And just putting those values in there, which gives me 0.9. And then once again I do exactly the same as before. So to find the next yn, so this will be the y2, I do y1 plus h bracket times the answer to this thing here. So again, just put the values in, so I get 1.1 plus 0.1 bracket, and then I put in my value for here, which is 0.9. So I get 1.19, and it gets slightly tedious. So as before, well, now n is 2, xn is 0.2. I then use this value, there's 1.19. Again, I put these two values here into my function, I get 0.79. I then put all these, so my yn goes here, there's my 0.1, there's this answer, that goes in there, I get 1.269. Same again for this one, and then if I work through, you can possibly pause the video and check that you get this correct. Then I should end up with this thing here. So I do all of this, and I finally end up with 1.38949, and that's it. So this is, remember, when n is 4, this is just worked out y4 plus 1, so this has worked out y5, which is basically the approximation that I wanted, you know, the fifth step in this sequence here. So there we go, 1.38949. I need to remember to round this. Obviously I don't want to give too much accuracy, so I'm going to round it to 3 significant figures, and therefore the answer is 1.39.